Hello, this is College Shark doing some math today in geometry. We're going to prove lines are parallel. So before we had parallel lines, now we're going to prove that they're parallel. And we can prove how they're parallel using the converse of the theorems that we learned last time. So starting off with the corresponding angles converse. If we have two lines and they're cut by a transversal, so transversal T. And if the corresponding angles are congruent, so this one and this one, so if angle 1 and angle 3 are congruent and angle 2 and angle 4 are congruent, then the lines are parallel. So if two lines are cut by a transversal and two corresponding angles are congruent, that means the lines are parallel. Another way to show that two lines are parallel is if alternate interior angles are congruent. So here's two lines cut by transversal. Alternate interior means opposite side on the inside. And then same thing here. Alternate exterior, so there and there. And then remember, consecutive interior means so on the inside, on the same side. So angle 1 plus angle 2 equals 180. Or consecutive exterior. Let's call this 3 and 4. So angle 3 plus angle 4 equals 180. Alright, let's do some examples. So for what value of x will line M be parallel to line N? Set up an equation, then solve, write a reason for each step. Okay? So, we're going to say statement, reason 1. 71 equals 2x plus 3. Why? Because they are corresponding angles converse. Okay. 2. We're going to subtract 3. Get 68 equals 2x. That was through the subtraction property of equality. And then 3. Divide by 2. Divide by 2. 34 degrees. Which through, division property of equality. So if x is 34 degrees, then line M would be parallel to line N. Okay. So checkpoint 1, same thing. Statement, reason. These are corresponding angles. So 1, 5, x minus 7 is equal to 98. That's because of corresponding angles converse. 2 we're going to add 7 to both sides. So that's the addition property of equality. We get 5x equals 105. And then we're going to divide by 5. I don't have any space. But you would put, oh, maybe I can get some notes here. There we go. So the third one, you would get x equals 21. And that was through the division property of equality. Alright, let's move on. How can you tell that the sides of the flag of Nepal are parallel? Okay. So they're talking about these two sides here. How do we know that they're parallel? Now, if you see the red transversal that I'm about to draw, and then they tell us that these two angles here are congruent. So if those two angles are congruent, we can use the alternate interior because they're on the inside, and then they're on the opposite sides of the transversal. So alternate interior angles converse. And remember, the converse says if the alternate, if two lines are cut by a transversal and alternate interior angles are congruent, that means these two lines are parallel. Alright, checkpoint 2. If you know that measure of angle 1 plus measure of angle 2 is 180 degrees, can you prove A is parallel to B? Yes, you can. Explain your reasoning. So because measure of angle 1 plus measure of angle 2 is 180 degrees, then they are supplementary. They are supplementary. Since they are consecutive interior angles, so because measure of angle 1 plus measure of angle 2, that means the angles are supplementary. And since they are consecutive interior angles, then this proves A is parallel to B. So because measure of angle 1, measure of angle 2 adds up to 180 degrees, they're supplementary. Since they're also consecutive interior angles, this proves A is parallel to B. Because we have this theorem that says if two lines are cut by a transversal and consecutive interior angles are supplementary, then the lines are parallel. All right, time for a proof. All right, here we go. Statement, reason. So whenever you're trying to do a full-blown proof, You always start out with what you're given. So A is parallel to B, given. And let's also tack on measure of angle 1 is equal to measure of angle 3, given. 2. So angle 1 is congruent to angle 3, and that's just straight off our given there. If two angles have the same measure, then they are congruent. And then 3. So angle 1 is congruent to angle 3. Now let's look at that. So if I look at this line, these two lines here, and I'm going to use, oh, okay. So they tell us that A is parallel to B. Let me draw that in. Arrowhead, arrowhead. So I can say, I'm also going to say that angle 1 is congruent to angle 2. And these are because these are corresponding angles. Corresponding angles postulate. So that says if two lines are parallel, which A and B are, and they're cut by a transversal, or let me use a different color. So I'm looking at angles 1 and 2. We know that A and B are parallel, and they're being cut by this transversal X. So angle 1 and angle 2 are corresponding angles, therefore they're congruent. Okay, now I can say therefore angle 2 is congruent to angle 3, and that's through transitive property. Angle 1 is congruent to angle 3, or if angle 3 is congruent to angle 1 and angle 1 is congruent to angle 2, then angle 3 is congruent to angle 2. So transitive property. Or you can say if two angles are congruent to the same angle, then they are congruent. Lastly, I can say X is parallel to Y. Because if I look at this one now, so I'm trying to prove, let's use colors, trying to prove that the two green lines are parallel. And what I showed was, so let's use the transversal here, A. So ignoring this side, two and 3 are alternate exterior, and they're congruent. So because they're alternate exterior and they're congruent, that means these two lines, the two green lines, are parallel. So alternate exterior angles converse. So we say converse when we're trying to prove two parallel lines. We don't say converse if they are already parallel. So let's review this proof. So they gave us some stuff and we wanted to prove x is parallel to y. So we can show x is parallel to y a few ways. Now, if you remember from your algebra days, we can use the same slope. So if we had the same slope, then we can show that they're parallel. But we don't have anything like that here. We don't have any numbers. So we have our other theorems. How do you show that two lines are parallel? We have corresponding angles. If we show that those are congruent, then we can show the lines are parallel. We have alternate interior, alternate exterior. If we show that the consecutive interior add up to 180 or consecutive exterior add up to 180. So one of those choices we needed to go with. But normally with these proofs, it all starts off with what we're given. So for example, they gave us A is parallel to B. A being parallel to B, meaning, so A is parallel to B, and if I look at this transversal here, and if we ignore the rest, we can look at angles 1 and 2, and we notice that those are corresponding angles. So my statement 3, angle 1 being congruent to angle 2, came from the fact that lines A and B are parallel. My second statement, angle 1 is congruent to angle 3, that came from the given measure of angle 1 is congruent to measure of angle 3. If the measure of two angles are the same, then they are congruent. And then we get, now we're trying to prove that x and y are parallel. So I needed a transversal that I could use and two angles that I could use. I used 2 and 3. So I needed to show that 2 and 3 were congruent, and because angle 1 is both congruent to angle 3 and angle 2, that means angle 2 and angle 3 are the same. And then finally, we know that this and this are alternate exterior, so we can use that to prove that these two lines are parallel. Once again, if these proofs are scaring you, you'll get more and more practice as time goes on. You might not be a master, and that's perfectly fine. We're introducing you to this type of thinking. Want you to be more logical in how you argue, in your arguments. And I think that is it for today. Have a good one.